Okay, then holding current. Holding current means this is also the forward current below which the SCR switches from its on state to the forward blocking state. In the first video, we discussed that how it switches from its forward blocking state to the on state. But in holding current, it's exactly opposite. That means from its on state to the forward blocking state. The minimum current that's required, or the minimum current below which the SCR switches from its on state to the forward blocking state. So how to find that holding current in this SCR? Initially we got these values for those to find the latching current 53.6. Okay, that's the latching current. I told how to get those values. Then increase that RPS voltage like 7, 8, 9, 10, 11, 12 volt, like that goes on. Increase that voltage and note down the voltage across the anode and the cathode and the current through it. It is just to measure. You can measure till 20 volt, or you can stop after getting this latching current. Then to find the holding current, don't switch off any circuits after measuring this latching current, because the to measure the holding current, initially the current has to flow from the anode to the cathode. That means the SCR should be in a on state. So now the SCR is in on state. So we are getting here for let's say our RPS voltage is like a 9 volt or 10 volt. We are getting the voltage across anode and the cathode as 0.72 and 55 milliamps as the current IA. Okay, the SCR is in on state. Now to measure the holding current, we just need to remove the have to remove this gate connection. This gate connection is there. No, we just need to remove this gate connection. Okay, I will remove this gate connection. Yeah, just remove this gate connection. Now the circuit is only this much. Then we just need to decrease this voltage across the anode and the cathode step by step. Decrease, not increase, decrease. And note down the value of the current through this anode and through the anode, that means through the SCR. Here you can see, by removing the gate connection, I'm decreasing this RPS voltage which is connected to the anode and the cathode. So here you can see that the current is also decreasing, and at certain condition I'm going on decreasing. That means from 10 volt, 9 volt, 8, 7, 6, 5, 4, 3, like that I'm decreasing this RPS voltage. At certain voltage, that means like 1.6 volt or 2 volt, like this, at that time there is a this current which is goes on reducing. No, that current becomes zero. Here you can see 1.44, this is the voltage across the anode and the cathode. The current is 7.6 milliamps. After that the current suddenly becomes zero. That means the SCR switches from its on state to the forward blocking state. At the blocking state, it is not going to conduct the current. So we are getting this current as zero. So this 7.6 milliamps is there. No, this is the holding current. That means that much of 7.6 milliamps that has to be remained, or 7.6 milliamps below which the SCR switches from its on state to its forward blocking state. If you maintain this 7.6, then the SCR is in a on state. if we come below this 7.6 milliamps, then the SCR, it switches from its on state to the forward blocking state. So this 7.6 milliamps, this is our holding current. Latching current is 53.6 milliamps. We just need to remove this gate connection. Remember this. Then we need to decrease the RPS for measuring the holding current. Okay. And then the breakover voltage. We already measured the values for this latching and the holding current. So breakover voltage is 6.4 volt. That means after this 6.4 volt, there is a huge drop in the voltage. That means the current start flowing through the SCR. It switches from its forward blocking state to the on state. So this is the forward breakover voltage 6.4 volt. Okay, at which we are getting this IA as the 0. After that, the IA is suddenly increase. Then we need to measure some forward resistance, that's on state resistance of the SCR. On state resistance means, for measuring the on state resistance, first we need to draw the graph of this VAK and the IA. Okay, here is the graph. This is a graph of VAK and IA. Okay, this is VAK and this is IA. It's 10 milliamps, 20 milliamps, 30 milliamps, and here 0.5 volt, 1 volt, 1.5 volt. So here I explained for this Ig1 equal to 3.12 milliamps. For that milliamps, here we can see at 6.4 volt, 6.4 volt, that's the forward breakover voltage, 6.4 volt. And here we can see that here it is 53.6, no 50, yeah, this is this voltage. What is that? Latching current 53.6. Here we can see that 53.6, that is a latching current. And here we need to draw the graph of this VAK versus IA by looking at that this data. Then in that graph we need to take delta IA. This is the correct node. Delta IA means small portion of the delta IA, and delta VAK. Delta VAK means, if we consider the slope, we need to take the delta IA versus the delta VAK. Delta VAK means it's a small voltage here. You can see, I can zoom here. Yeah. Here you can see that delta IA and delta VAK. From here to, okay, I will show it. Yeah, here you can see this much small, that is delta VAK is 0.1, and from here to here delta IA, that is 88 milliamps. So that's the forward that means static resistance of the SCR, that's VAK by IA. So we are getting 1.1364 ohms. That's it. Thank you.